You may remember this interstellar visitor. It was the first rock we ever saw hurtling through our solar system from beyond the Oort cloud. Scientists were excited. Finally, we could answer so many questions about the distant outer solar system. And then astronomers made an astounding announcement. They believed the object was artificial, thousands of miles long, that it might be an alien spacecraft. If true, that would change our understanding of physics and life in the universe. But after all the hype, we now know that story had a few problems. Now scientists say they have the real story behind how Oumuamua began, but they still can't agree if it's boring or groundbreaking. Here's the strange journey of the interstellar visitor, and why scientists are calling it the most important comet of the century. In 1980, a team led by British astronomer Fred Hoyle popularized the concept of the Goldilocks planet, a world that orbits a star in the habitable zone, the region around a star where temperatures are suitable for liquid water to exist. The idea of the Goldilocks planet is that life as we know it is unlikely to evolve on worlds that are too hot or too cold. We find ourselves in a Goldilocks universe as well. There are stars that are too big, stars that are too small, stars that are too hot, stars that are too cool. But our sun, a main sequence star of medium mass, is just right. Astronomers estimate there are hundreds of billions of sun-like stars out there. So it stands to reason that there must be countless planets with similar conditions for life, right? Well, we don't have enough evidence to say that. There are two main reasons scientists haven't found a second Earth yet. First, space is really big. We haven't even explored 1% of it. Second, Earth might be special. Maybe the conditions that allowed us to evolve are rare. But a 2014 paper published in the journal Astrobiology proposed another reason. It's possible that panspermia is occurring. In other words, the building blocks of life might be traveling throughout the galaxy, seeding new worlds with the ingredients necessary to spawn life. The paper cited evidence that bacteria and organic molecules could survive in space for millions of years and suggested that rocks, ejected from planetary systems, could serve as interstellar vehicles for life to spread. Now, while the jury's still out on whether life can survive outside of a star system, astronomers do have evidence of rocks traveling between systems. Fast forward to October 19, 2017, when the Panoramic Survey Telescope and Rapid Response System discovered an unusual object hurtling through our solar system. The object was oval-shaped, spinning rapidly on its axis and tumbling as it approached the sun. At first, the object's reddish color made astronomers suspect it was a dead comet that had been broken apart by impacts. But as it got closer, the object started to spin faster and faster. And that's when scientists realized this wasn't just any ordinary rock. It was an interstellar traveler, a visitor from another solar system. With the name Oumuamua, which means scout in Hawaiian, the object became an instant sensation. The sheer excitement of seeing an object from beyond our solar system for the first time quickly overshadowed any scientific analysis. It didn't take long for people to start speculating that the object might be artificial, perhaps a massive alien light sail that was exploring our solar system. One group of researchers argued that the shape and movement of the object was proof of extraterrestrial design. Others pointed out that the object was speeding up too quickly to be a comet and must have been pushed by a powerful engine. Some even wondered if the object was a message from an advanced civilization. We might never know what really happened to Oumuamua, but according to Avi Loeb, chair of Harvard's astronomy department and one of the authors of a controversial paper suggesting that the object was artificial, here's how it began. In 2015, a rogue planet about 10 times the size of Jupiter passed within 1,000 astronomical units of a red dwarf star. An astronomical unit is the average distance between the Earth and the Sun. For scale, anything less than 50 astronomical units is considered relatively close. Anything between 50 and 200 astronomical units is considered far away. And anything beyond 200 astronomical units is considered extremely distant. By comparison, Pluto is located at 39.5. Oh, the object we now call Oumuamua was likely an icy body orbiting the red dwarf at a distance of 500 astronomical units. Then came the rogue planet, a gravitational bully that went around kicking objects out of their orbits. That's actually pretty common. In fact, some astronomers suggest that the giant Jupiter-like planet disrupted the early orbits of Uranus and Neptune. If you've ever seen those things you shouldn't put on a Christmas list, you'll know why. So this hypothetical rogue planet sent Oumuamua flying towards the outer solar system, but the story doesn't end there. When Oumuamua reached the outer solar system, it encountered a bunch of ice giants, and the gravitational pull of these gas giants pushed the object into a path that extended as far out as 0 astronomical units, only to return to the inner solar system again, like a bouncing ball. But it's during this second trip that the object became the interstellar visitor we know today. And while Loeb says his team has evidence that the story is true, he admits it might be wrong. It's also worth noting that while scientists were previously baffled by the object's odd acceleration, further observations revealed that it did in fact accelerate, but not in the way that they initially thought. Now, astronomers believe the object is most likely a gigantic pancake-shaped comet that was tumbling through space. That shape would explain why the object appeared to speed up as it approached the sun. As the sunlight hit one side of the object, the force caused it to flip over, exposing a darker area underneath, which scientists thought was artificial, when in reality, it was just a shadowed portion of the same icy surface. Even so, this discovery raised a lot of questions. Where did the giant pancake-shaped comet come from? And why did it have such a strange shape? According to a preprint posted to the archive, notably not a peer-reviewed journal, Cornell astronomers say they have the answers. In their simulation, the team showed how a regular old comet could be bombarded by micrometeorites, giving it the flat shape we saw. In fact, the team claimed that the object was so large that it wouldn't even hold its shape for 1 million years. That suggests that it was probably formed within the last 100 million years. So the next question is, where did it come from? According to the simulations, comets in the outer solar system tend to form in disk shapes. When our hypothetical comet formed, it spun fast, so fast that centrifugal force prevented it from collapsing into a sphere. Instead, it flattened like a disk. Then the gravitational tugging of the ice giants aligned the disk along its orbital path, creating the perfect pancake. As for how the comet made it all the way to Alpha Centauri, Loeb says it was simple. The red dwarf it was orbiting kicked it out of the system. In fact, astronomers already have a candidate for the red dwarf's identity: Ross 128, a star located 11 light-years away. That means the interstellar visitor didn't come from too far away. In fact, according to this hypothesis, the object might have formed in our own solar system. But if that's true, then why have we never seen it before? Well, if it was created 100 million years ago, it would have taken over 20,000 years to reach the Oort cloud, and from there, it took another 300 years to fly out of the solar system. So it's entirely possible that the object was hiding in plain sight the entire time. Even so, other astronomers aren't convinced. They argue that the simulations ignore the forces that would have broken up the comet as it flew through the dense asteroid belt between Mars and Jupiter. Either way, the story of Oumuamua goes to show how unpredictable science can be. Just because we think we know how something works doesn't mean we always get it right. The more we try to understand the universe, the more questions we find. What do you think? Is there a scientific discovery that blew your mind recently? Let me know in the comments below. Also, give this video a thumbs up. Thanks for watching.